Hello everyone, we are Team D and we would like to present our project on smart farming. The main aim of our project is to safeguard the soil from losing its fertility owing to poor farming techniques and to treat crop disease organically rather than using inorganic fertilizers during plant growth, which helps in protecting the soil properties. And also to cultivate the right crop in the right soil to reduce the risk of soil property degradation. Agriculture is an integral part of India's socio-economic fabric. Farmers' failure to choose the best crop for the land using non-scientific and traditional methods is a severe problem in a country where farming employs approximately 58% of the population. Farmers have occasionally failed to select the suitable crops based on the condition of soil, sowing season, and geographic location, which is why people commit suicide, leave agriculture, and seek employment in cities. To address the above mentioned problem, we have proposed a system to assist farmers in crop selection by considering all the factors such as sowing season, soil condition, and geographic location. In our project, we are using machine learning approaches like random forest, and this is due to the rising rate of plant leaf disease losses. This plant leaf disease detection technique can be used to detect a disease from the input image to solve the significant problem. In our project, we would like to develop a nature-friendly web application in which the following applications are implemented. That is plant disease prediction system, crop recommendation system, and fertilizer recommendation system respectively. We have considered a data set of about 87K RGB images of healthy and diseased crop leaves, which is categorized into 38 different classes. We'll be considering data sets for exploring and analyzing the suitable crop date from various trustworthy sources, including data.government.in and kaggle.com. This is the architecture. We have used Matplotlib, Scikit, Pandas, NumPy, PyTorch for our model training and preparation. We have gathered Python pickle file. We have generated Python pickle file. We have used Flask server for our web application. We have built the front end of the application using HTML, CSS, and JavaScript. Over to Nikita for further explanation.
Thank you, Samyukta. As a part of a project, I have worked on plant disease prediction. So the goal here is to build a model which can classify between a healthy and a diseased crop leaf, and also if the crop have any disease, predict which disease it is. There are various phases of the methodology. Here we used a region-based ResNet model segmentation technique for image segmentation. The input to image segmentation will be a data set provided by us, and the output will be the form of cluster data. Here we are using PyTorch. Also, we have found this data set, which is disease underscore finder.csv from Kaggle, which has 87,000 images. So when coming to the exploration part, we have loaded the data set that we have found, and then we have divided the data into train and validation, which are named as train underscore dir and valid underscore dir. So here I tried printing the total number of disease classes that are there in the data set. So the output is 38 classes. So out of these 38, there are 14 unique plants, and the number of diseases that are unique are 26. So we have images of leaves of 14 plants, and excluding healthy leaves, we have 26 type of images that show a particular disease in a particular plant. As I already mentioned, here we are using ResNet 9, a neural network architecture for image segmentation and object detection. On a general note, ResNets are a common neural network architecture used for deep learning computer vision applications. like object detection and image segmentation. Here, going forward to the visualization part, I tried plotting a graph to represent images for each class of plant disease. As shown in the bar graph, uh, the x-axis represents plants or diseases, and y-axis represents the number of available images for each class in our data. So images available for training are, there are 70,295 images that are available for training. So in the part of data preparation for training, we have used transform.toTensor function, and we have put it in image folder. Basically, it converts a PIL image to tensor. TorchVision.dataset is a class which helps in loading all common and famous datasets. It also helps in loading custom datasets. So I have used subclass torchvision.datasets.image folder, which helps in loading the image data when the data is arranged in this way, as shown here. Here, root slash dog slash xx.png, so on. These are the parts that leads to the images that we're using. This is the example. I tried to see the shape of the image. Uh, Here we can see that the shape is 3 by 256 by 256. Here 3 is the number of channels and 256 by 256 is the width and height of the image. Here I tried showing the images of some of the training data sets, which are tomato, healthy tomato, apple, peach bacterial, and so on. So we have considered the batch size to be 32 here. Coming to the modeling part, first of all, we are defining a default device function, which helps us pick the GPU or CPU, whichever is available. After choosing the location, we are moving the tensors to the device is chosen. And the third step here is creating a class device data loader, which helps us to wrap a data loader to move data to a device. After this, we have created train_dl and valid_dl data by using device data loader class, the model we created. Building the model architecture. This is the residual block code. Here we have used feed-forward neural networks by using back propagation. When coming to the training of the model, here we have used two main functions. One is the evaluate function, which performs the validation, and the other one is fit_1_cycle function, which performs entire training process. Here, after training and testing with the data we have got an accuracy of 99.2%. Below plots shows the validation accuracy, validation loss, and learning rate of our model over time. Here are the plots. The first one is validation accuracy. The second one is validation loss and learning rate over time. So when testing the model, we can see that the model predicted all the test images perfectly. So once the testing is done, we have saved the model. Here we have used say or load a state_dict to save our model. There are several ways to save the model in the PyTorch, but we have used save or load state_dict function. So ResNets perform significantly well for image classification when some of the parameters are tweaked and techniques like scheduling, learning rate, gradient clipping, and weight decay are applied. The model is able to predict every image and test set perfectly without any errors. So the remaining part will be covered by Samyuktha Guda. Thank you.
Thank you, Nikita and Samyukta. So one of the other model we are working is crop recommendation model. In this crop recommendation model, firstly, our main aim is to generate pickle files, which takes numerical inputs. This is because in order to work our web application, so then the generated pickle files are to be embedded in a web application. Then in this data cleaning is performed, and to check the similarity between two features, we have performed the correlation matrix here and separating features and target label. Here we are taking nitrogen, phosphorus, and potassium values from the user, and then we hit open weather API and then finds temperature, humidity, rainfall, and by considering all these parameters, picks which crop is suitable and the steps to grow the crop from the dictionary buffer as output. So here, rather than just giving the name of the crop, we are trying to show the steps to grow by using dictionary buffer. We are using machine learning models here to find the accuracy for each model. Here we used decision tree model and a navy bias, uh, support vector machine, logistic regression, random forest, and XGBoost, and then generated pickle files. So using the best algorithm which has got high accuracy is used to build our model. Here we used random forest since its accuracy is 99%, which you can see accuracy for each model here. And the and the random forest has got the highest, which is of 99%. So our main aim is to, rather than just running the code and displaying the output, we built a web application using Flask. This is all about crop recommendation. And coming to fertilizer recommendation, we perform same process as crop recommendation using machine learning approaches. But for fertilizer recommendation, we didn't find any particular data set. So we have prepared our own data set based on some researchers and books. So here we are just using dictionary buffer to generate the results. Adding you to the web application. So this is the web application we have built. So we have built a user-friendly web application that considers rainfall, temperature, soil type, and other factors that directly affect cultivation. The main goal is to increase the number of crops grown throughout the season. The developed scheme would assist farmers in minimizing the difficulties they face when picking produce and maximizing yield. So this application has three modules: crop recommendation, plant disease prediction, and fertilizer prediction. This website provides numerous services. First, the farmer must complete the registration process to use the app. The farmer can use the web application services after a successful registration. I can show you a login. So here, if the user is new, he must create new account first. If the user has already signed up to the account, he can sign in. So after completing the registration process, the user can use the app. So in this prediction, crop prediction, uh, the module predicts the crop yield using selected attributes from the data sets for the specific crop. For example, consider nitrogen value as 4 based on the given input given by the user. Potassium value as 3, pH value. As of now, some random values were selected. Yeah, based on the given parameters, the users, our application suggests to grow mung bean in the farm, and the steps to grow are also mentioned here. Then coming to the disease prediction, the farmer can also check the disease of the crop by uploading the image here. Here, our application predicts the crop is apple and the disease found is cedar apple rust, and the cause of the disease is also mentioned, and the prevention to cure the disease is also mentioned here. And then similar for the fertilizer prediction, nitrogen value can be selected, and then phosphorus and potassium. So here, based on the parameters given, it suggests the nitrogen value of the soil is low, and suggestions are also given to successful production of the crop. So yeah, this is a web application we have built. Thank you.